All right, 15.1a, Intro to Logarithms. Now, this is kind of a big deal. This lesson we're going to spend today and tomorrow on it because it goes through going from exponential form over to logarithm form and going from logarithm form to exponential form. That's one of the most important skills that you can have with logarithms. Now, before I get into logarithms, I actually want to talk to you about something. And this was kind of like something you might have seen on last night's homework. But if I gave you something like this, let's see, 10. How do you solve for x? Multiply? Square it? Why square it? Why not cube it? Why not raise it to the fourth? Why not raise it to the eighth?
We don't know.
It's hard to answer, isn't it? Yeah. You have, however, solved something like this. Because that, you would just do this, right? And then you'd go to your calculator and you'd take the cube root of 10 and you'd get whatever decimal that is. We have not, however, solved something with an x in the exponent, other than last night when you were just guessing and checking. Okay? Logarithms are how we solve this. But before I get there, let me talk about some educated deduction that I can do here. I know some things about this. I have absolutely no idea what the answer is. But I do know some things about powers of 3. I know that that's true, correct? And that's sort of close. Yeah? I know that this is true. Right? And that's not really close. But I do know that 10 is between 9 and 27. So can I conclude from that that x is going to be between 2 and 3? If 10 is between 9 and 27, x is going to be between 2 and 3. So I'm going from knowing absolutely nothing about this problem to now knowing that x is going to be 2 point something. Right? That's progress, yeah. Can I say that 10 is closer to 9 than it is to 27? Yes. A lot closer, right? So that makes me feel like x is going to be a lot closer to 2 than it is to 3. Yeah? So anything beyond that is still just a guess. I don't know if x is 2.1 or not. It's probably pretty close to 2.1 if it's not, but I don't know what it is exactly. I can just narrow it down to a area of what it is. I can make an educated guess now at this point. Logarithms will help us get the exact answer. Now, whenever we are solving an equation, whether it be that one where we take the cube root or whatever, we're always trying to get x by itself, right? So I got to get that x out of the exponent in order to get it by itself. And that's what changing from log form to exponential form is going to do, or vice versa. So starting off with something that's given to us in exponential form, I have 2 to the third power equals 8. Is that a true statement? Yeah. Yes. And that is written in exponential form. B to the x equals y. Something to the x power equals y. We need to change it over to logarithm form. How do you know the difference between logarithm form and exponential form? Well, logarithm form has the word log in it. Exponential form doesn't have the word log in it, and it has an exponent. Okay? So, what do you notice about the way the letters rearrange here? X and y switch. So x comes first, then y. Over here it's y first and then x. In both cases, b is the first thing you see, correct? Now, why do they use b, x, and y? Why not, I don't know, x, y, and z? Or w, x, y? Why do they use b? Well, b is standing for base. So we have a base of a power, and that also is called a base when it's down here in your logarithm. All right? So, what's the base of my power here? 2. So, in log form, the base is going to be 2 also. Now, let me talk about this base. This base is in what we call subscript. Does anyone know what subscript is? What is it? It's a little number. How is it different than superscript? Superscript is also a little number. Superscript is a little number at the top, aka an exponent. Subscript is a little number at the bottom. So you physically have to change your font in order to type that into a computer. Okay? The next one, the next number is no longer subscript, but it's made up from these two numbers. And what did we have to do? We saw the x and the y became a y and an x. So my next number is not going to be 3, it's going to be 8, not subscript, and then equals 3. Didn't I say if there was an x in the exponent, we needed to get that exponent out of the exponent in order to get it by itself? We just got it out of the exponent. Okay? So right here, we're just going to practice writing it from one way to the other. So I'm going to jump down to 81 equals 3 to the 4th. Now this one's written backwards because my exponent's on the right. So I'm going to actually just go ahead and write equals 81 just so that I've got it in the same way. What would this be? This would be log base what? 3 of what? 81 equals 4. Pretty easy. How about this guy? Log base what? 625. Yes, you can have large numbers. Yes, you can have fractions as bases even. Of what number? 25 equals 1/2. Okay, how about this guy? This guy's backwards, isn't he? So I'm going to put the equals 1 over 27 here. As you get fluent with this, it doesn't matter what way it's written. What do I have now? Log base what? 3 of what? 1 over 27. They may or may not put that in parentheses. Means the same thing either way. What does that equal? -3. And then finally, 1 equals x to the 0. I want to look at that the other way. X to the 0 equals 1. So what do I have? Log base of 1 equals 0. Pretty easy, right? Okay, let's go the other way. So now I have something in log form. I need to put it back into exponential form. So what's the base of the log here? 4. So that means 4 is going to be the base of my power. And then what am I doing with those two numbers? I have to switch them back. 3 has to go back to being the exponent, and 64 goes back to being there. Is this a true statement? Does 4 to the 3rd equal 64? Yep. Okay. What about right here? This would be what's my base? To the what power? -2 equals 1 over 64. Is that a true statement? Yes, a negative exponent gives you that fraction and bumps the 8 squared down to the bottom. What about this guy? What's this going to be? 49 to the 1/2 equals, is that a true statement? Yeah. Yes, because we all know, hopefully, that a 1/2 exponent means a square root, right? Okay. What would this guy be? 14 to the 0 equals 1. Is that true? Yes. Yes. Okay, let's try these two guys. What's this one? A to the what? 1 equals, is that true? Anything to the first power equals itself. Okay, what about this last one? A to the x equals a to the x. That makes sense, doesn't it? I believe that's called your reflexive property in geometry. Okay, I'm not going to make up another example. I think we get the idea. But a chunk of your homework tonight is just going to be, I give it to you in one form, you rewrite it in the other form. Okay, just practice going back and forth. Now I'm going to come over here. You saw some notation like this on yesterday's homework. F of x equals log base 6 of x. Find f of 36. What is this problem telling me to do? Plug in 36 for x. So that means I really have log base 6 of 36. And is it okay if I call this, instead of saying equals f of x, can I call it equals y? Just for shorthand. Okay? Now, I don't really know what to do with that. If you try and go to your calculator, it's not going to be any help. So I'm going to try and go to exponential form. What would this be in exponential form? The base would be 6 to the what power? Equals 36. So what is this question really asking me? What is the exponent that I have to put on a 6 in order to get a 36 as my answer?
2.
That exponent has to be a 2. So my answer here is 2.
Y equals 2.
I would just write 2. Don't worry about the y equals. Okay, let's look at this guy. Log base 36 of x, but I don't want to put in x, I want to put a 6. Now don't just jump to a conclusion that this is going to be the same answer as the previous one, because it's not. I'm going to say equals y. That looks like I'm trying to write an exponent there. I'm not. This is just regular. Woohoo. So, what is this in exponential form? To the equals, what does the exponent have to be on 36 in order to get 6 as your answer? 1/2, because we know that 1/2 means you're taking the square root. Pretty reasonable? Okay. So those problems you should be able to work through. This one right here is about as hard as they get right now. Okay? And this one is a bit tricky. But this one can help you if you're stuck on any of those questions on the back of last night's homework. This can help you with them. So find f of 8. Well, I have, let's see, log base 1/4 of 8 equals y. What would this be in exponential form? 1/4 to the y equals 8. Now I'm stuck here. Yes, I know that I have a 1/4 and an 8. One of those is a fraction, one of them is not a fraction. And hopefully from yesterday you remember that when you have a fraction going to a non-fraction or a non-fraction going to a fraction, then there's something negative about the exponent, right? But beyond being negative, can 4 to some power get me 8? No. Because 4 to the first is 4, 4 to the second is 16. No power of 4 gets me 8. That's where this gets tricky. So I need to think about 4 and 8, and I need to write them as a power that has the same base. So I need to think about a number that is smaller than 4 and 8 that I can put an exponent on to give me 4 and 8. 2. So instead of 1/4, I'm going to call this 1/2 squared to the y equals 2 to the 3rd. You okay with that? This is trying to get what we call matching bases, and that was the issue on, what was that, 17 through 20 section on your homework last night? You had to get these matching bases. Now, because this is a fraction, it's still kind of messing with me a little bit. So I'm going to call this, instead of 1/2 squared, I'm going to call it 2 to the -2nd. I'm going to go backwards. Is that okay? To the y equals 2 to the 3rd. And then if I simplify here, I have 2 to the -2y equals 2 to the 3rd. Now, have I gotten y by itself? No. And have I helped myself at all? Well, not a whole lot, because I have helped myself, but what I'm looking for is still in the exponent, isn't it? But if my bases match, I have 2 to this exponent is equal 2 to this power. Doesn't this exponent have to equal this power? If they're going to be equal, if this expression is equal to this one, this is going to have to equal that. So as soon as I have my bases matching, I can set -2y equal to 3 divide by -2, and guess what? Y equals -3/2. There's my negative exponent that I was looking for, and that's my answer. Now, yes, you may have 1 or 2 of those to challenge you for a bit, and we're going to work on them more tomorrow as well. This one is really the most difficult type, though, for right now. Okay? These ones shouldn't be too bad. I'm going to ignore those for right now. And now I'm going to talk right here. Now, I'm going to do a big old highlighted circle here, because This is the number one place I get questions. And I will get questions later on about this, and they'll be like, what's a common log? I don't know what a common log is. And I'll say, look at the front page of your packet. It was right there. Okay? There are certain conventions that we use in math that are assumed. For example, if you take a square root of something, say square root of 8, it's not a nice number, but what is the implied index right there? A 2, correct? If I have something like this, what's the exponent on it? A 1. We don't write it though, right? What's the coefficient? 1. Everybody knows that, but we don't write it, correct? Logarithms have their own situation like that, and that is if you have a logarithm that has no base, it is base 10. So log of 1,000 is really log base 10 of 1,000. Okay? So how would you write this in exponential form? 10 to the third power equals 1,000. Now I tell you that because if I hadn't written this underneath and you just saw log of 1,000, everybody goes, I don't know what the base is. What do I do? Well, it's a common log, which means you need to be able to know that that means base 10. Make sense? Okay. That is also the base that your calculator uses. And you do need to be familiar with your calculator. However, you also need to be able to do everything that I've done so far without a calculator, because you will have a quiz, I believe possibly on Friday, where you have to do something like this without a calculator. Which over here, a calculator wouldn't even help you. Right? The rewriting stuff. These ones maybe, but your calculator isn't going to help you if it doesn't have base 10. You notice the log button on your calculator has no base with it. But if you look at your calculator also, right above it, mine has a 10. 10 to the x. It's a different function, but it reminds me that that's a base 10. Okay? So let me jump down here to this problem right here. Log of 5. If I wanted to find that, this one says evaluate with a calculator. So if I punched in log of 5, I'm going to get a long, ugly decimal. With logarithms, it is traditional that we round off to 3 digits past the decimal. Don't ask me why. Some textbook probably decided that was a good place, and people just do that from now on. So I have 0.6989. What am I going to round that off to? 0.699. So if it says round to the nearest thousandth, that means give me 3 digits past the decimal. So what did I just solve? Log of 5. Well, if I wanted to check this, doesn't my answer mean that 10 to this power equals what? 5? Isn't that what it would look like in exponential form? Let's check that. Is 10 to the 0.699 power equal to 5? Darn close to 5. 5.000343 or 345, whatever. Why isn't it exactly 5? Because I rounded. Okay? If I didn't round, if I just did log 5 and then I did 10 to my previous answer instead of rounding off, whoops, 10 to the previous answer, there's my exact 5. As soon as I round off, I'm going to be slightly off, but I should be pretty close. Okay? The other one we need to know is called a natural log. That's another button, should be right next to or right underneath the log button on your calculator. It says ln, that is a lowercase l, and I can't tell you how many students tell me, oh, it's in, or it's 1n, it's in. No, it's natural log. ln. It is a log. It would be written like this, but what it means is that it has a base of e. So when I see ln of 10, I really should be thinking log base e of 10 equals x. What would that look like in exponential form? E to the equals 10. So let's calculate ln of 5 on our calculator. ln of 5, 1.6094. What am I going to write as my answer? 1.609. And let's check this. If I were to take this and write it in exponential form, what's the base? E, right? Base of E to the 1.609 equals 5. That's what I'm saying my answer equals. So if I want to check it exactly, I'm not going to use the rounded off form, right? I'm going to use the previous answer, E to the previous answer. And I should get exactly 5. There it is. Okay? Kind of sort of makes sense? Okay.